Now we're going to try some practice problems. So here is the graph we're presented with, and this was originally posted by the National Review on Twitter. Their argument was that climate change is not real, and this graph supports that. So you can take a minute and pause the video if you are watching this on your own, or if you're watching this live, then I will do that for you. And just try to think to yourself, what is wrong with this graph? So the problem with this graph has to do mostly with our vertical axis. So here we have on the y-axis or the vertical axis, we have what the average annual global temperature is in Fahrenheit. But if you look, this graph starts at 0 and goes all the way up to 110. Now, when we are looking at a graph with this kind of data, that range of numbers is not necessary. Like, they have completely diluted the data in order to make the trend line seem insignificant. So when we look at this graph, it is the same data, but instead it's shown on a more appropriate vertical axis, or y-axis, however you want to say that or are most familiar with. And see, it's much more clear now where this trend is going. You can see that it is going up. Now, some people may look at this and they may be like, oh, 57-ish compared to 58.5-ish, that's not a lot. But, so the reason for this has to do with statistical significance, all right? So now we're going to watch this video to explain why statistical significance is important.
What is statistical significance?
Why do you ask?
I heard that a study shows that the male and female brains are not different and that the study was statistically significant.
Did you read the study?
No. I just want to know what statistically significant means.
What does significant mean?
I don't know. Large?
You can have a statistically significant result and yet it may not be large.
Then why is it significant?
There's this thing called p-value.
P-value?
It is a type of probability used to determine if a study result is statistically significant.
You are making my head hurt.
When you run a study to see if there is an effect, you need to compare your result with the standard situation. This is called the null hypothesis.
Null hypothesis?
Yes. If the effect measured in your study is different from the null hypothesis, you may have a statistically significant result.
What is the null hypothesis in this study?
The null hypothesis would be that there is no difference between male and female brains.
Huh? No difference. So if I found any difference, isn't that significant?
Perhaps, but we have to set some threshold on what we call statistically significant. We call that threshold the confidence level, usually 95%.
How do I know if my results meet the threshold level?
You have to calculate the p-value for the results of your experiment. Then you compare your p-value with the confidence level. I'll tell you how to do that in the next video.
So when we look at this graph, the statistical significance of the data has not gone anywhere. Just because this trend line looks flat does not mean that there is no relationship between climate change and increasing average annual global temperatures. That statistical significance is still there. And this graph is misleading because it dilutes that significance. Now, there are also problems with this graph. For one, the average global temperature on the vertical axis, they should have labeled if that was in Celsius or Fahrenheit. They did not do that. They also do not have labels on the Y and X axes. I mean, yeah, it's pretty obvious that these are years, and these are degrees, but they still should have labeled that. They also ideally would have put a break in the graph before they started the vertical axis. Now let's look at a bar graph from a Russian news outlet that depicts the country's growth of COVID-19 cases. The growth of the curve seems to slow down as you move from March 5th to March 31st, but can you spot the deception? All right, so until March 26th, the visual increase of cases corresponds to the numeric increase, right? Like we have 658, so our little bar comes up here, right? So we can look at March 24th, where it says 495, and that is about twice the size as on March 20th, where it is 253, right? So that's pretty proportional. But then once we hit March 27th and onwards, the visual increase no longer corresponds to the numeric increase. So they have stopped scaling the bars consistently. If you'll see on our vertical axis, they have not included a vertical axis that we can see. They are just reporting these numbers. There is no vertical axis to be heard of. So they have visually flattened this curve from March 26th onwards. Even though cases are still rising, they have made these little visual representations, the bars, they have not increased them proportionately to the numeric increase. Because if we crunch the numbers, the growth rate stays about the same. Like we have 288 new cases on March 28th. That is a 22% increase, but looking here, you wouldn't think that, you know? From March 29th, we have 270 additional cases, which is a 21% increase. March 30th, 302 new cases, a 20% increase. I would think that looks like a 2% increase, you know? March 31st, 500 new cases, a 27% increase, but it does not look like a 27% increase. So they have intentionally messed with the scale of these bars in order to deceive viewers so that it looks like the curve is flattening in Russia. And so when we look at this, here is what that graph should look like. And if you'll see, this looks, oh no, this looks much more exponential than the previous graph. See here, where it looks like we are flattening the curve, you can tell there is no such flattening occurring. We are still going up, up, up. Now take a look at this graph. Are interest rates going up? Would you submit a bar graph like this to your teacher for a grade? You know? All right, so here we can see a side-by-side comparison. This is the same data, but with a different y-axis. So when we look at this graph, the y-axis is scaled so small that any statistical significance, even if there were one, would not be evident. There is no way for us to say that a 0.02% difference is statistically significant in regards to interest rates. So then when we look at this graph, we see the y-axis is scaled more appropriately. So if you are at our live workshop, we will now stop this video and discuss what we've learned, take any questions, comments, concerns. And if you are not at the live workshop, You can email me, go to our website, ask questions in the forum. Yeah. I hope you enjoyed it, and I hope you learned something.